Welcome back. Now that you understand how a level shifting IC works, let's move on and talk through working with an infrared obstacle sensor. This sensor is going to come in handy later in level D when you build the robot. After all, it is not as much fun if your robot keeps crashing into things. So in this video, you'll learn how to work with an infrared obstacle sensor, which will be on the robot later in level D. Now, a quick note about this picture. Marvin here has 4 sensors attached to the bottom of his chassis. The 2 outside sensors, those are the blue ones, are infrared obstacle sensors, which we're going to focus on in this video. You have 1 IR obstacle sensor in your level B kit, so you can learn to work with it proficiently. The level D kit includes 2 more, which you'll attach to your robot's chassis in lesson D6. Now, the 2 inside sensors, the black ones you see in this picture, are infrared line sensors, and you'll learn how to work with those in the next video. An infrared or IR obstacle sensor is a device that uses infrared waves to determine if an object or surface is near the sensor. A 5-volt output line is used to report whether or not an object is near the sensor. This output line can be level shifted down to 3.3 volts and connected to an input on your Raspberry Pi, allowing a program to know if something has come close to the sensor. And this is why we talked about level shifting in the last video, because you're going to need it to work with this sensor. The obstacle sensor included in your kit has an active low output, which means that when no object is detected, the output line will have a high or 5 volts present. When an obstacle is detected, this output line will go to ground or 0 volts. Your program must be coded to understand that high means no object has been detected and that low represents that an object is near the sensor. Okay, so let's look more closely at how the sensor is constructed in the pinout. The sensor contains an infrared emitter and receiver located next to each other. The infrared emitter constantly sends out infrared signals, and the receiver is constantly waiting to receive those signals back. If an object is close enough to the sensor, the emitter signals will bounce off the object and reflect back to the receiver. The sensor then knows that something is close, and the circuitry on the sensor board will pull the output pin low, indicating an object is near. If an object is not close enough to reflect the emitted signal back to the receiver, then the sensor will know that no object is near the sensor and the output pin will remain high. The infrared reflectance of an object is its ability to reflect infrared energy. This reflectance will determine how far away a sensor will see infrared reflected from that surface. So a wall in your house will have a fairly high level of reflectance, so the sensor will likely be able to detect it from 4 to 6 inches away. A furry blanket or pet will have a low infrared reflectance, which will likely lower the detection distance down to 2 inches or less. And I can tell you from experience that your dog or cat will generally decide to move out of the way before the robot gets within 2 inches of them. The detection distance will also be affected by the angle at which the emitted infrared contacts the surface of the object. An object reflecting perpendicular to the sensor will offer the highest level of reflectance, allowing for the greatest possible distance detection. The further an angle is from 90 degrees, the lower the amount of reflectance that surface will offer, which will lower the detection range. An IR obstacle sensor can be added anywhere that touchless object sensing is needed. They might be used for obstacle avoidance on a robot or to sense the presence of your hand to run part of a program. These sensors will only detect objects in a narrow area in front of the sensor, so their alignment may need to be adjusted to ensure they cover the desired area. To get coverage for the tire area on the robot, sensors can be mounted at a 45-degree angle. This will allow for angle detection while still providing some front detection at short ranges. Okay, before you move on to the next video, let's take a few moments and review the concepts we've discussed in the last 2 videos. First, digital signals operate at high and low, but not every device has the same voltage for a high signal. The Raspberry Pi, for example, uses a high signal of 3.3 volts, but many components use a high signal of 5 volts. It's really important never to connect a 5-volt device directly to the Raspberry Pi. The integrated circuit included in your level B kit allows input signals of 3.3 volts to be shifted to 5 volts and 5 volt inputs to be shifted to 3.3 volt outputs. And this makes it possible for those 5 volt components to be used with the 3.3 volt Raspberry Pi. And then in this video, we discussed how an infrared obstacle sensor uses infrared waves to determine if an object is near. The 5 volt output line is level shifted down to 3.3 volts for connection to the Raspberry Pi and operates as a low active output. And this means that when the pin is high, no object is near, but when the pin is low, an object has been detected. The emitter on the sensor is constantly sending out signals, and the receiver is constantly waiting to receive those signals back. Now, the obstacle sensor has a fairly small range, but is useful when you need to detect objects that are close by, like when you need to prevent your robot from running over something or crashing into a wall. Go ahead and move on to the next video where I'll show you how to use infrared line sensors.